Hey guys, Mr. Roden here. Today I want to introduce you to the extra credit assignment that I'm going to be offering to the geometry class, and it's going to be on what we call medians of triangles. Okay, so I'm going to show you kind of how we do a median of a triangle, and just some things to think about, and then I'll tell you at the end kind of what I'm going to expect if you would like to do this extra credit assignment. Okay, so let's go ahead and get started. So let me go to my construction tools here. And what I've constructed, guys, is I've constructed just a regular triangle, okay? And so I'm going to go ahead and just put these sides in here. So this is, let's say this is angle A right here. We won't be too creative. We'll just do the whole ABC deal here. Have angle A, we have angle B, and then we have angle C. Give me 1 second here, guys. I'm going to go close my door because a class just got let out. All right. So the first thing you want to do is you want to measure the sides of your triangle. Okay. So I'm going to go ahead and pull this down. And what you want to find here, guys, is you want to find the midpoint of each one of your triangles. Now, we could do a bisector with a compass, but I'm fine with you just measuring. So this is 9. So the midpoint of this is going to be at what? That's going to be at 4.5, right? So we're going to make a mark at 4.5 right here. So let's see if I can make that mark. It's not letting me make a mark right. It's going to make a mark right there at 4.5. Okay. All right. Did it make a mark there for 4? Let me just see if I can get that. It's going to be about 4.5. So it's right here. Right here. Looks like it was about right here. I'm going to have to just estimate just because this tool is not very good. All right. And then I'm going to do the same thing here. I'm going to rotate it around here. I'm going to take my compass. And you're going to do this on, well, I'll show you in a minute. I'm just kind of showing you what a median is. All right. So this guy right here looks like it's 16. Just for the sake of time here, I'm just going to say this is about 8. Okay. So I'm going to pull this down here. We're going to say it's at 8 here. Okay. We're going to say it's at 8. There's the midpoint. And let's just say I measure the other point and say it's right here, okay? So let's say the other point is about right here. Okay, so these are midpoints here, all right? Now, the median, what you're going to notice, here's what a median of a triangle is, and I'll change the colors here. A median of a triangle is you start at the, like we're going to start at A, and we're going to connect a segment that goes all the way to the midpoint of its opposite side. So this blue segment right here, that is a segment, and I'll call this ABCD. We'll put a D right here. So segment AD is a one median of the triangle. Okay, guys, got to see what medians are, and then let me change the color on another one, and then we have another median. And another median could be from B to this mark right here. And we'll call that E right there. And sorry, that's it's kind of messy here. Get rid of it. Just the ruler's just not very good on this line maker tool, this geometry construction tool. So we'll call this A, B to E. We'll call this BE right here. Okay, BE. And then we'll do another one. Now, if you do it right, now I didn't measure super precise here just because the ruler's not very good on the geometry tools. But here's the deal. The next thing is, if I do another one, now you're going to notice that my midpoint should have been about right here, actually. Okay. So what's going to happen is you're going to get these medians to be concurrent. Okay. So we'll call this F. So if you actually do measure it correctly, you're going to get these three medians. And remember what a median is. It's a line that connects an angle to the opposite midpoint. Angle to the opposite midpoint. Angle to the opposite midpoint. And they actually happen to be concurrent if you measured correctly. And this is a very special point right here. I'm going to go ahead and put my compass on it. Okay, this is a very special point right here. This point has a name. It has a pretty cool name right here. We'll make that, let's do black. That point right there, ladies and gentlemen, that point is called the centeroid of the triangle. The centeroid of the triangle. Okay? The centeroid. I'm going to pull up my OneNote and write this all out. And we're going to talk about what are some things about the centeroid, and then I'll tell you what we're going to do after that. Okay, so I'm going to go ahead and pull my OneNote up because I can write much easier. But I wanted to show you that you're going to measure the midpoints of each side carefully. You got to measure very carefully, and then you connect the opposite angle and that point of the midpoint, and those are called the medians. Okay, so let me pull up my OneNote really quick. Okay, so I've constructed my medians here, and I just kind of estimated here just because I don't really have a ruler for my OneNote here. But let's pretend that D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. Now, they should be straight lines, guys. They got to be straight with a straight edge. I had to just kind of freehand it because my line maker tool isn't working great. All right, so this point right here, like we said before, we'll call that E. We'll call that point G, and G is called the centeroid of the triangle. The centeroid. Now, the centeroid is the point of concurrency where the three medians of the triangles intersect. So they are concurrent because all three of them are going to go through the same point at G. Now, this centeroid has got some really cool things about it. First of all, we've got the 2/3, 1/3 rule. Okay? So 2/3 of the length of the centeroid is going to be between the angle and the centeroid. 1/3 is going to be between the centeroid and the other side. So it's 2/3, 1/3. Again, 2/3 is going to be between the point, the angle, and the centeroid, and 1/3 is going to be between the centeroid and the other side. 2/3 here and 1/3 over here. So the first thing we get is the 2/3, 1/3 rule of centeroids. So remember that because you're going to need to know that in your extra credit activity here. And the last thing, which I think the coolest thing is, this centeroid is also what we call the balance point. The balance point. Okay, it's the center of the gravity. It's the center point of the triangle where it'll actually balance on itself. So if I take I have a very special pencil, and if you take a triangle and if let's say cut it out, and I'll tell you in a second, and you put it on its centeroid, if you truly did find the correct centeroid, the triangle should perfectly balance on that point. All right. So here's your extra credit assignment. Okay, so here's your extra credit assignment. I want you to find a large piece of stiff cardboard about the size of your desk, okay? This is the desk you sit out in Jenkins. Find a cardboard approximately the size of your desk. It can be a little bit smaller or a little bit larger, but make sure it's stiff. Don't get poster board because poster board is floppy and it won't work. Use a straight edge to construct a triangle on the cardboard. Then cut it out. I want you to try to use as much of the cardboard as possible. So try to make a big triangle. I'm trying to make these triangles fairly large. I don't want little teeny triangles. I want very nice sized triangles. I want you to measure the midpoints of the sides of the triangle and actually mark those on your cardboard. I want to know where those midpoints are and mark them on your cardboard. Then I want you to construct the medians of the triangle and show they are concurrent at point G. So you're actually going to construct the medians just like I did on the construction tool, and you're going to show that they are going to be concurrent. If they're not concurrent, you did something incorrect. They must meet at one point. If they're not all crossing at one point, you know you did something incorrect. You're going to show the 2/3, 1/3 rule is correct and write the lengths on the cardboard. So you're going to actually measure the entire length of the median. You're going to take 2/3 of that and show that that 2/3, 1/3 rule actually does work. If you have any questions about the 2/3, 1/3 rule or anything really, just let me know and I can kind of explain that to you. You're going to bring your triangle in on Wednesday, 12:15. And then here's the moment of truth. You're going to bring your triangle up in front of the class. I'm going to take my very special balancing pencil that I have that balances all the triangles over the years. It's a very special pencil to me. It's in a secret location that I hide. And then if I can balance your triangle on its centeroid, you will receive 5 extra credit test points. And those are test points. Those aren't homework points. So that could be like you got a 35 out of 30 on your test. It will add 5 points to your last test. So if you want to do that, that's a great way to add some more points onto your test. Is I will add 5 extra points onto your test, and that will be on your second quarter report card. All right, come see me if you have any questions, guys, and good luck. I'm looking forward to seeing if your triangles balance. All right, see you later. Bye.